In this lesson, we'll introduce some important concepts that will help you understand cryptography's role in the world of blockchain. Cryptographic ciphers are encrypted and decrypted with keys. These keys are basically secret pieces of information or parameters which typically look like strings of characters. Think about something like a password or passphrase that locks and unlocks access to an encrypted message. These are actually keys to the cryptographic algorithms and help convert ordinary information, called plain text, into unintelligible text, called ciphertext, and vice versa. There are two main types of cryptography: symmetric, also known as secret key cryptography, where the same key is used for both encryption and decryption, and asymmetric, also known as public key cryptography, where the key used for encryption is different from the key used for decryption. Let's provide a very simple example describing the difference between the two types of cryptography, shall we? A cat wants to send a dog a hello message, but doesn't want anybody else to be able to read the message. If it uses the first technique, the cat will have to share the same secret key with the dog. It will encrypt the plain text hello into ciphertext using the shared secret key. Once the dog receives the ciphertext, it will be able to decrypt it with the shared secret key, and that's that. But it isn't always convenient to share your secret key with an external party, right? It is much more convenient if both parties have their own secret keys and come up with a mechanism to be able to share information with each other. This is where the second type of cryptography can help us. In this case, the cat encrypts its hello message with the dog's public key, a key available to everyone, and this converts the plain text into encrypted ciphertext, which is then decrypted by the dog with its private key, a key the dog hasn't shared and shouldn't share with anyone. And this is how the second type of cryptography works. Actually, the second type of cryptography is the one used to provide security and privacy in Bitcoin and other cryptocurrencies. Actually, the Bitcoin blockchain is the largest civilian deployment of public key encryption technology in the world. Only the U.S. Department of Defense makes a larger use of such technology, which says a lot about its merits. Several cryptographic techniques are used to secure the Bitcoin blockchain, including public and private keys, hash functions, and digital signatures. Any person who has ever used a cryptocurrency to make a transaction should be familiar with how keys work. Each user has a pair of keys, a public and a private one, which enable transactions on the network. You can see here some examples of public and private key pairs in Bitcoin. The public key is used by the sender to encrypt information regarding the transaction, which can then be decrypted only by the receiver with his or her corresponding private key. The public key can be shared openly as it serves like an address or account which can only receive funds. The private key must be stored securely and never disclosed, as it and only it gives access to the user's funds on the blockchain. If the private key is lost, access to the funds is lost permanently. There is no such thing as a password reset function on the blockchain. Users need to take responsibility for storing and backing up properly their private keys because there is no central authority on the network that can reverse misplaced transactions or restore private keys. Please make sure you understand well the implications of any loss of private keys and take all measures to avoid it. You should treat the private keys for your Bitcoin or other crypto assets with the same care you treat any physical cash, gold, or diamonds you may have. The difference here is that you can back up your private key, as it is a string of characters that can be copied. Therefore, you can print it on paper, save it on a USB memory stick, or use special devices called hardware wallets, like Ledger or Trezor, that can securely store your private key. In our next lesson, we'll explore another major application of cryptography in Bitcoin, cryptographic hash functions. Thanks for watching.